Thank you for downloading this podcast. We want to know your entrepreneur story and how we can offer the help that means business. Enter Entrepreneur SA with FNB on 702.co.za or capetalk.co.za.
Stand up for the law. Stand up for decency. Stand up for compassion. Stand up for respect. Stand up for your community. Stand up for your future. Stand up for South Africa. LeadSA.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
24 minutes to 10 o'clock. Chris, good morning.
Hello.
Hello there. Well, we didn't start the show on a positive note. Everybody's just so upset. There's been a horrible story of a young girl who was abducted on her way to school. She was allegedly raped and her charred remains were found in a farm near Magaliesburg. So people have been reacting to that. We've been talking about DNA tests. Why don't we have that kind of system so that we can follow, especially repeat offenders? But somebody wants to know why DNA tests take so long to conclude.
Well, it's really important that you do tests like this really carefully, because anyone following the international news last week who saw Amanda Knox, the American lady from Seattle, be released after 4.5 years in an Italian jail, following people calling into question whether or not that evidence was correctly handled in Italy following the murder that she was alleged to have taken part in. Well, you can appreciate that it can have a big impact on people's lives if we get it right and if we get it wrong. And in order to do these things correctly, you have to make sure that they're very carefully controlled. Now, it doesn't take that long to actually do the physical scientific tests. In fact, you can do it in one evening, really. But in order to make sure that you've got it right, that everything's being handled correctly, it takes a lot of people, it takes a lot of expertise. Marshalling all of that and then checking everything takes a lot of time. But it depends on if we're talking time in terms of a few days or a few years. It should certainly take days rather than years to do. And if it's taking longer than that, then something's wrong.
And in fact, one of our stories this morning, Chris, has a lot to do with the DNA. Tell us about that.
Well, you're probably referring to a very nice paper which is published this week in the journal Nature. It's by a group of researchers internationally, but the lead author is a lady called Kirsten Boss, who's at McMaster University in Canada. And this is a historical story, a real history yarn, if you like. It goes back 600 years. Now, many people have heard of the Black Death, the plague which came to Europe in the Middle Ages between about 1344 and 1348. About 50% of Europe died in that period, some 30 million people at the time, of this horrible disease which caused black buboes on people's bodies. They developed high fevers. The graveyards were overwhelmed and they had to start buying new land off of people to bury bodies in. So many people were dying. And there's always been a question about, well, what was the cause of the Black Death? What arrived in Britain and other countries in order to wipe out so many people so quickly and spread like wildfire? Now, when they've done previous analyses, they've connected a bacterial infection called Yersinia pestis to the Black Death. And Yersinia pestis still exists today. It causes plague around the world. But that leads to the question, well, we don't have episodes like the Black Death today, but we've still got the bug. So was the bug that was causing the Black Death back 600 years ago different to the bug that we have today? Was there something special about the one that caused the Black Death? So what this group did was to go to a museum in London where they have the remains of 600 bodies that were removed from one of these plague pits in East Smithfield. That was in the 1980s, and they've kept these pieces of material in the museum in pristine condition. They were able to drill into the teeth of some of the bodies. They actually took teeth from 2 females, one juvenile and one body of unknown sex. They got DNA from those teeth, and of course in people who died of the Black Death there was an overwhelming bacterial infection, and that meant that also in the bloodstream of the patients was the DNA of the bacteria. So from the DNA extracted from the teeth they were able to also extract DNA from the bug, and although the DNA was quite degraded, having been underground for so long, by using millions and millions of copies of the genetic material made in the laboratory and then getting a computer program to piece together all the little pieces, because the DNA was very fragmented, and work out which bits overlap with each other, rather like doing a giant jigsaw. they have put back together 4.5 million genetic letters of the entire genome of this Yersinia pestis strain that killed people 600 years ago. And then they set about comparing it with the genetic sequence of the Yersinia pestis that we have today. What did they find? Expecting to see some dramatic differences that would account for its virulence, they were very surprised to see virtually none. And the Yersinia that was around 600 years ago is almost unchanged compared with the strains we have today.
Yeah.
And also, interestingly, what the data reveals is that it hadn't been in humans very long when it caused the Black Death. It probably emerged in humans as little as 100 years before it then unleashed the Black Death on the world. And it was the Black Death that probably then carried the bug all over the world as it spread during that pandemic. But this is really interesting because what it says is something else made the infection much worse. Perhaps it was the genetics of the people. Perhaps there were people around at that time who carried some kind of propensity when they caught this infection to get really sick compared with other people. Those are the ones that have died, leaving behind the population that we have today who are much less vulnerable. Perhaps there was something about the climate. Perhaps there was another infection circulating at the same time, and when you got both things together, you came off much worse. Or perhaps it was just a social situation at the time. People lived in very poor conditions.
Right.
There were lots more rats and fleas around which spread this bug. Perhaps that was the reason. But it's certainly a fascinating story, and to be able to piece something back together after all this time is wonderful.
I just love the combination of science, biology, history, all of that. It's quite fascinating indeed. Let's go straight to the lines. Helen, you're calling us from Glen Hazel. Hi.
Hi, Reedy. I'd just like to ask the scientist about how do people become allergic to medication, and is there a way to find out what they're allergic to and solve the problem?
Nice question.
Yeah, hi. Well, allergies, in the classic sense, are caused by an overreaction to an antigen. And most antigens are little bits of protein which come from some source. Usually they come from outside the body, but sometimes you can get autoimmune conditions where you actually start reacting against antigens in your own body, but that's slightly different. When you have a classic allergy, you have what's called a type 1 hypersensitivity reaction. Usually what this means is that you have made antibodies, which are called IgE antibodies, and these antibodies recognize some kind of substance which, when you come into contact with it, those antibodies detect the substance, and they are connected to cells called mast cells that live in your mucous membranes, and these mast cells are packed with histamine. And when the antibody locks onto the antigen, the allergen, the thing you're reacting to, the mast cell pumps out histamine into the local tissue, and histamine has lots of effects. One of them is it initiates an itchy reaction. The other is that it opens up blood vessels, which makes your tissue swell, and another action is that it makes blood vessels leaky, so that the blood comes out, or proteins from the blood come out into the tissue, and that makes it swell up. So the cardinal features of having an allergy are that things become itchy and swollen and hot and tense. And that's what's going on in the area where you're exposed to the allergen. In terms of controlling it or testing for it, you can do something called prick testing. So when someone has these funny allergy symptoms, what they usually do is go and see an allergy specialist, and they can introduce into the skin a tiny dose on the end of a needle of a range of different antigens, and you then leave it to cook for half an hour, and then you look for a flare or a wheal. In other words, a red swollen area where you've initiated the allergic reaction to a small scale locally, and if any of the little dots where you put the needle in come up red, then you know that there's probably an allergic reaction to that thing. And if you have hay fever, for example, that's what you can do to find out what you're allergic to. Controlling it, well, this ranges from doing simple things like avoiding the thing you're allergic to, which sounds simple, but it's actually the most effective, through to simple drugs like antihistamines. By blocking up the receptors that histamine binds to have those effects, you can actually stop the person having some of the effects, or they're less severe. And then you can go a bit more dramatic. You can give people steroids, glucocorticoid drugs, damp down the immune response so that the person doesn't have as big a flare-up. And then there's even more catastrophic immunosuppression if it gets really bad, but most people don't get to that stage, thankfully.
Okay, thank you very much, Helen. And Merle in Constantia, hi.
Hi, Reedy, and hi, Chris. I'm wanting to know, what is an itch? What causes, I think this is related perhaps to the last caller.
Yeah.
What is an itch? What causes it? And why does scratching relieve it? I listen on the radio. Thank you.
I think we did have something like this a couple of years ago, but let's go through it again. No problem.
Hello, Merle. I think it's almost certain that there will be many people who are now scratching in sympathy, because a bit like yawning, when someone mentions yawning, you want to yawn. Itching and itchy things make you want to itch in sympathy. We don't actually know what an itch is. We have a pretty good idea that there is a special population of nerve cells in the skin and other bits of the body, which, just as you have nerve cells for fine touch and stroking, for pain and other modalities, we also think there's an itch-specific population of nerve cells. And these are nerves which, when they're active, they signal to the spinal cord. Some people have found some of the chemicals that they use to talk to the spinal cord. There's one called gastrin peptide releasing. I think it's called gastrin receptor releasing peptide, or similar name. And this is one of the proteins that is used to convey the itch sensation into the spinal cord. So the bottom line is, when you have an itch, you have a certain population of nerve cells active. They tell the spinal cord that the patch of body that they supply is itching, and therefore that signal is conveyed up to the brain, and you pay attention to it. Why do we have this reaction or ability? Probably as a defense against parasites and skin irritation. If something makes you itch, then you pay attention to that body part, and often parasites and other inflammatory conditions trigger an itch, and therefore it's a good way of making you pay attention to the affected body area. Scratching probably works, because when you scratch, you're initiating low-grade, low-level pain in that area. And there's evidence that when you initiate pain in an area of the body, the pain nerve fibres inhibit or switch off the supply of activity to the spinal cord in the itch nerve fibres. And it's a bit like, if you hurt yourself, then you often rub or kiss the area that you've hurt better. And that is a way of sort of light touch making pain feel better. Well, we think that pain makes itch feel better. So when you're scratching, you're actually giving yourself low-grade pain to inhibit the flow of itch sensations.
Thank you very much. This is Merle for the question. And an SMS here, Chris says, a friend had a liver transplant, and his doctor told him, you cannot transplant livers across racial lines. I don't believe him. Please, can Chris confirm or deny this? That's Derek.
Well, there's some truth in this, in the sense that in order to do an organ transplant, unless you have an identical twin, the person that you're getting the organ from or giving an organ to is going to be genetically distinct or unique from you. And the immune system is very good at discriminating self, i.e. you, from non-self, someone else or something else. So if you put tissue into the body which is not you, the immune system can tell that it's not you, and it mounts a reaction against it because it presumes it's some kind of foreign invader and needs to be attacked. And you have both antibodies and you have cells that unleash a very fierce chemical attack on the presumed invader, and they can destroy it in minutes. So when doctors do organ transplants, what they're doing is matching the organs genetically so that they line up a number of important genetic markers that tell the immune system whether or not this is friend or foe. And because some people share more of those markers than others, then you need to check carefully the person you're going to take the organ from and see if their genetic spectrum, if you like, matches closely to the intended recipient. Now, because when humans were evolving, they diversified and went off all over the planet and formed individual groups, which is why we have black, we have white, we have Indian, we have Chinese and so on. There are clusters of genes which migrate and co-segregate with certain populations. So if you take a liver or a certain organ from one population, they're less likely to share some of those markers with people from another race or population. It's not impossible, but it's much less likely that they'll have some of those markers. And so that can mean that it's harder to get a match to do the transplant. And for that reason, some ethnic groups in some countries will find it's much harder for them to get an appropriate organ than other ethnic groups, for example.
Let's go to Linda. Linda, you're calling us from Lone Hill. Hi.
Hi. I just want to find out, the veins on my hands swell quite a bit in summer and when I'm stressed out. And my doctor doesn't seem to think it's, that's serious. So they never give me anything to relieve it. It's just very uncomfortable, though. So I just want to know if, there's a scientific reason behind the veins on my hands swelling.
Hi, Linda.
Hi.
Well, the reason why veins distend or open up is because they're your body's natural radiators. the body diverts more or less blood as appropriate through the superficial tissues when it's too hot or too cold in order to lose or heat or conserve heat. So if you get too warm, you open up blood vessels near the surface of the skin, and this means that you can put warm blood close to the outside world, and you can supply sweat glands to make more sweat, and this is a really good way of cooling the surface of the skin. Blood going in means you've got to have more blood coming out. Veins, which are more superficial, are the route back out of the tissue towards the centre of the body. So if you're putting more blood in, you've got more to go into the veins coming back out, so they appear to swell more, and by being more full up, then they're going to radiate more heat out of the body and help you cool down. And I think that's more likely, if you're saying it's happening on hot days, that's probably what happens to you, because we use our fingers and hands as very effective radiators. There are actually ways for the nervous system to exclusively dilate arteries and arterioles in the digits in the fingers. And that's because fingers have a very big surface area to volume ratio. In other words, there's lots of surface and not a lot of core to the finger. So the blood has a chance of getting very close to the surface. So they're very good at losing heat for you. So we use our hands as mini radiators in order to keep ourselves at the right temperature. And I suspect that's probably what you're seeing. Although if it's a new thing, if something's changed, then it might be worth getting it checked out in case there's something new happening in your hands. But it sounds like you're just doing what your physiology does best, keeping you the right temperature.
Kosi in Bryanston. Good morning to you, Kosi.
Yes, hi, Rudy. I just want to find out, sometimes if you're looking, there's some kind of like jelly-like little squiggles that are in the eye. They look like they're outside, but they're moving around. Sometimes they can be like a color, or they're sort of semi-clear.
Like a mucousy type of thing in your eyes.
Yes, like a jellyfish type of thing that moves around. What
is that? Okay.
Hello, Corsi. These are floaters. Floaters have another connotation, which are things you sometimes find in public lavatories. But in the context of your eyes, they are definitely different. And these are small particles which are in the liquid which is in your eye. If you were to cut into an eyeball, you would find that right at the back of the eyeball, towards the inside of your head, is the retina and blood vessels. And in front of that is something called the vitreous humor. It's a jelly-like substance. And in front of that is then the lens capsule, and there's some fluid in there, and then at the front is your cornea, where you would put your contact lenses, for example. So the light has to come through the lens, get focused onto the retina, passing through all these other structures on the way through. And because these structures are jelly-like or liquid, then things can move around in them, and occasionally there's bits of debris, bits of material, old cells, which float around. And when they pass through the light, which is coming in from your pupil and being focused by your lens, they go in front of the light before it gets onto the retina at the back of the eye where you see it, and they therefore create a tiny shadow which spreads out as it gets towards the back of the retina, because if you've got light coming in and you put something in the way of it, then you'll get a shadow which gets bigger the further the light travels towards the back of the eye. So you're effectively seeing a shadow of an object which interrupted the path of light coming through your eyeball and your focusing system. Most of the time they're perfectly harmless, and pretty much everybody reports them most of the time, and for most people they're not a problem. If you get a lot of them all of a sudden, or you see like black rain coming down, this can sometimes be a sign that your eye is not healthy, and that perhaps the vitreous humor, the liquid inside the eye, is detaching from the back of the eye. If you get that symptom, it's worth seeing somebody about it. But if you just see the odd jelly-like wisp, as Rudy was saying, perfectly normal. Those are called floaters, and they're a well-known phenomenon.
Okay, thank you very much, Kosi. And Dick in Somerset West, you've got a follow-up question to the Black Death story.
Yes, very quick one. Since those bodies were so very, very old, how were they identified as having been victims of a plague that took place over a few months' time? I'll look on the radio.
Very good question, and the answer is that they were in the right place at the right time. So we know exactly when they were buried, because records document when the bodies went into these plague pits. This plague pit wasn't a normal cemetery. It was land that was purchased, and there are deeds recording the purchase of that land specifically in order to put bodies into, because they had nowhere else to bury all these people who were victims of the plague. And then you've got the presence of this pathogen at the right place at the right time. So you've got Yersinia pestis turning up in the plague pits, in people who are in those plague pits at a time when the plague was raging, and they're not finding other common infections. So it all fits together. Obviously, it doesn't prove 100%, which is why I'm saying that the researchers themselves acknowledge that there's no difference between the Yersinia genetic code that's in those people in the plague pit and the genetic code of Yersinia today. So there has to be some other factor superimposed on top of it, but it does look like the common feature is this particular bacterium. We just need to find what else triggered it to be so virulent in these particular people.
Here's an SMS here. Penny wants to know, why do some women suffer from postpartum depression?
Yeah, baby blues is very common, and a very high percentage, maybe 20% of women will say that in the weeks immediately after giving birth, they may succumb to postnatal depression, and the symptoms can be quite severe in some people, as in disabling severe. Why does it happen? We don't actually know, but there's a number of good suggestions. One is that when you have a new baby, it's exhausting. You've gone through a tremendously traumatic birth process, which is very, very tiring. You then have a baby who keeps you awake night and day, often. Ours certainly do. And that's in itself stressful. And you're also trying to learn to cope with a new way of living. You've not just got to worry about yourself and your family, your close family, but you've now got a baby who depends on you, and those things can be stressful. So it could be that. Also, there's a huge hormonal surge and an ebb and flow which comes with having a baby, because the hormone levels that were maintaining the pregnancy change very dramatically as soon as the baby is born, and that sudden change in hormone levels is thought also to affect mood and make people more vulnerable. So it might just be that it's all these things add together, and in some people who are less well supported, they may manifest or perhaps they have a tendency to manifest postnatal depression. Fortunately, it can be relatively easily dealt with, and as long as people are well supported and they see someone who can help them, then they generally get better quite quickly. There are, of course, exceptions, and some people do find that actually they suffer quite badly with it.
Okay. Well, Chris, thank you very much for chatting to us. We chat to you next week again.
Thanks, Reedy. Have a great weekend, everybody. See you soon.
Bye-bye. And, of course, you can download the podcast. Give us an hour or so after the show, and Thomas will put it together for you. And you can also go further and go to www.thenakedscientists.com.